Hi everyone, this is Professor Shashikant Pathak from National Institute of Education. Welcome to my series of short How to Learn videos. In this video, we will learn about exponent laws. So here I have a quick review of what we are going to learn after this video. So we will start from product law and then quotient law, power of a power, power of a product, power of a quotient, integral exponent rule, and rational exponents. So let's get started with the product law first. And before that, I just wanted to define here that if I have a variable x with power m, then in that case, normally what we call x as base and m as base, and m is called as exponent. So I'll just define here for you so you understand clearly that x to the power m, where m is known as exponent. So let's start with the first one, which is product law. So I'm writing here product law, and product law is that if x is to the power m multiplied by x to the power n, then that becomes x to the power m plus n, and this is a plus sign here. So with same base here, the powers are added. That's what the product law says. Thereafter we have quotient law. So quotient law, we have x to the power m divided by x to the power n. What we get? We get x to the power m minus n. So we have same power here, same base here, and but different powers, so powers are subtracted in division. Thereafter we define power of a power. So let's write down power of a power, power of a power. So how we write that? We can write here x to the power m first, and then we put a small bracket and then power n, and thereafter we do the operation, we get x to the power m multiplied by n. So what happens here is that when you have power of power, both power they get multiplied. Now let's go to the next one, which is power of a product. So let's write down power. Let's change the color here. I think it's not very bright here, so let's change the color. So power of a product, power of a product. Let's talk about this one. In this one, if I have two variables and they are multiplied as xy, and if I take a power here m, so as soon as you open the bracket here, then the power goes on each of them, so that becomes x to the power m and y to the power m. Thereafter it comes to the power of quotient. So let's write down power of quotient, power of the quotient. In power of a quotient, if I have x divided by y to the power m, we did multiplication here, now we are doing a division here for x upon y to the power m, then we get x to the power m here, and we get y to the power m here. But now here there is an important point to understand, that y to the power m is in denominator here. The condition is that y should not be equal to 0, because if y becomes 0 here, then this total value becomes 0 and you get infinity. So that's not allowed. So y is not equal to 0. And thereafter it comes to integral exponent rule. So I'm just writing here integral. Let's go back here, rewrite it. Integral exponent rule. Right? So integral exponent rule is if I have x to the power minus m, then that becomes 1 upon x to the power m. And this is very easy to understand, because basically what happens here is here you have actually 1 is upon 1 also, but normally we do not write it as upon 1. That's why I did not write it earlier. But for understanding, you should understand that as you have minus m here, that minus m becomes plus m when it goes to from numerator to denominator. In the same way, this one will also be x not equal to 0, because if x becomes 0, the value becomes infinity. So that's why that is not allowed. Okay, so now let's come to the rational exponents. Let's write down rational exponents. So in rational exponents, if I choose here x to the power m by n, so m by n is basically there are two powers here, and if you do this operation, you get here, let's rewrite it as m into 1 upon n, right? And then I can write it as x to the power m. I can put a bracket here and write 1 upon n outside. So basically what happens here is this is nth root of x to the power m. So I can rewrite it as n and then here under root x to the power n, right? But you see, the important point with rational exponents is that the order does not matter here. Basically, order means m and n. M and n order does not matter. Order does not matter. That's an important point to understand. So to understand this part, what I would like to do, I would like to do this operation again to explore that how it works. So if I take x to the power m upon n again, I can rewrite it as slightly differently. Let's write down it 1 upon n here, and then I can multiply it by n here. Let's put a bracket here. Understand? Thereafter, I can rewrite it as x to the power 1 upon n, bracket closed, and power m here. Thereafter, again we can write it as this is nth root inside. So again nth root of x here, but then we can put a bracket to the power m. So the value here, what we obtain finally here, this one, and this one here, they are same actually. They're not different. So essentially, m and n order does not matter. That's an important point for rational exponents. So that's conclude our discussion about exponent laws, and I will be following up this video with more questions and problems solved on exponent laws, and so just follow it up, and thanks for watching.